Hello, everybody. Welcome to my talk. In this talk, we will focus on telling a journey, or actually a story, what we went through in Datadog, and how we were detecting and fixing the misconfigurations at Datadog scale. So, before we start, let me introduce myself. So, my name is Adam. I work in a Datadog's cloud security team. I have been a member of the team for more than a year and a half. I am coming from a system and network engineering background, and security has always been my background. But for the past 7 years, I have been purely focusing on security. In my free time, I also like to play with the latest technology and tinker around and try to see what problems I can solve with it. In the name of the talk, I'm mentioning Datadog scale. So what exactly is Datadog scale? So as you might know, Datadog is a multi-cloud company. Our services are running on top of hundreds of Kubernetes clusters, and these clusters are backed by tens of thousands of nodes. These nodes are backed by hundreds and thousands of cloud resources, and we have more than 2,000 engineers in our engineering organization creating changes. So basically, sometimes it can happen that the misconfiguration can bleed in, and we want to avoid doing so. So for the context of this presentation, I would like to define what do we consider a security misconfiguration. So I was actually thinking, and then I settled on a definition that basically security misconfiguration is a configuration that makes the system less secure. So think of it like, for example, public S3 bucket, open Redis port, open internet ports through security groups, expose databases, snapshots, and so on. Why are actually these misconfigurations dangerous? So imagine that you are working for a company that is dealing with the health data of the customers, and suddenly this data appears on the internet, and you are basically facing sensitive and confidential data leak. Sooner or later, somebody will notice, and this will result in compliance violations, and regulatory authorities might actually come in and provide regulatory fines. At worst case, it could lead to loss of the compliance level, which would render business basically the company not being able to do the business in a particular field. And last but not least, malicious actors could exploit the misconfigurations in order to launch attacks or to basically gain access to more company resources. Over the last couple of years, there have been some high-profile cloud security incidents. Some of them are related to the sensitive data leaks, such as health data or personal information. Others are about credentials leaks, and some common attacks such as server-side request forgery were used. To get to know more about this, I recommend the talk by my coworkers from a security research team that I think should be in this track later. And yeah, what are actually challenges when dealing with the misconfigurations? So the first and foremost, it's scale. Imagine that your company has hundreds and thousands of cloud resources. You have a big engineering team, and they are working on hundreds and thousands of services. So basically, trying to know what to remediate, what to fix is actually and how to approach it it adds to the complexity. Then our engineers in Datadog are releasing new features daily, and this also results in a lot of changes to the underlying cloud infrastructure. And basically, if I remember infrastructure from yesterday, my knowledge of the infrastructure is already outdated. And basically what is constant in our environment is the change. With so many people involved, imagine that you have an S3 bucket and there are 20 or 30 teams using it. The challenge of not having a clear ownership is always a problem, because if you have a problem that you want to report, who are you going to report it to? After you have identified the owner, then trying to get the owner to fix the particular misconfiguration is also a challenge on its own. And it's also important for security teams to be always kind of honest with themselves, that if what we are asking teams to fix is really the most important things. So if I ask them to prioritize finding A over finding B, will it lead to a risk reduction? So now that we covered the misconfiguration, let's talk a bit about the detections. So with detections, when you are thinking about how do we do them in Datadog, first things that could cross our mind was basically when and where do we detect these misconfigurations. So we ended up, basically Datadog is undergoing a bigger shift left initiative, and we realized that basically having as early as possible, and we want to avoid the misconfiguration from going to production. Some of the requirements that became obvious after we have talked with our stakeholders were basically that we need to provide feedback pretty much when they are just drafting the code or iterating over in pull request and it hasn't been merged. For our own internal needs as a cloud security team, we are scanning code repositories daily so we can spot the bigger trends. And in case that we miss a misconfiguration, we still need to have a mechanism. How do we detect it post deployment? This naturally led to focusing on two areas. So basically development and basically infrastructure as code. In Datadog, we use Terraform. In infrastructure as code is a mechanism, or actually a practice where all of the cloud resources are managed by code. And then we have a runtime, which we consider any active cloud resources, basically anything that has been deployed. So how do we select tools for detections? So the good news is that market is quite mature and there are plenty of excellent tools on the market. They are both in open source and commercial offerings. They differ in different capabilities or mechanisms how they scan, extensibility. Some offer you to write custom rules, others do a correlation between the finding and the code repository, so it's easier to locate it within the source code. The way how we actually choose the tools when we are thinking about it, so basically we aligned that, again, we had the business need and we wanted the tool to fit the bigger picture. When we were choosing the tool, we were focusing on capabilities rather than features. All of these tools, they have a lot of features, but trying to choose the tools by features basically sometimes led us to rabbit hole, because we just got lost into the details that were not necessarily important. And we ended up picking one tool that basically provides the biggest bang for buck. Another big thing that one has to be careful with tools is that they should start small. So always pick one tool. And the false signal to noise, or actually the false positive ratio, is quite significant here. Imagine that you are building a pipeline and suddenly you start reporting 2,000 findings to developer, and they basically get a victim of alert fatigue and they basically lose the sensitivity. So basically nothing will get fixed. Always keep in mind that plugging more tools is easy, because detections are one of those things that are done easily. But when you keep using more tools, always mind the tool overlap. So how do we do detections in Datadog? So to provide a bigger picture, It starts with the code change. Then we do an iteration through the continuous integration system. Once the developer is happy with the result, the findings have been, misconfigurations have been fixed, then the continuous deployment will take it and deploy the code to the production. And then we are entering the maintenance phase where basically the resource has been created and we are using the standard cloud resource lifecycle. So basically code change and CI/CD would fall under the development and maintenance would fall under the runtime detections. So let's talk a bit about infrastructure as code detections. So as mentioned, in Datadog, we use Terraform. We reviewed a lot of tools, but we agreed and aligned on Checo. The reason why we chose the tool was because it was easily extendable. It supported everything we needed and had a lot of policies or actually checks from the beginning. The way how we deployed the tool was basically in two modes, so-called pull request mode and schedule mode, which I will cover briefly. This tool, Chekhov, is basically running a CI/CD pipelines, but we also have written some internal tools that basically try to extend the capabilities to basically provide more context. So, for example, if the resource has tags, or we have more information such as the owner, service, and so on, we always try to provide more context to the finding. So when whoever is looking at the finding, they have the context. And this tool is also integrated with an internal reporting platforms. So, for example, we are sending data and we are able to generate metrics, draw dashboards, collect graphs, and so on. On the pull request mode is the one that is executed as a part of every continuous integration run. So basically, every time a developer creates a Terraform code change, the PR mode would be of Chekhov would be actually activated. The main point of this mode is to basically catch misconfigurations early and posting comments in every pull request. On this picture, you can see a sample comment where basically we try to provide the breakdown by files and then particular resources. And we always try to link to the resource within a source code and the findings, the description of findings. The important thing about the finding is that it is pointing to the Chekhov documentation. And this documentation actually provides a lot of clarity about what is the impact, why is the problem, and how it has to be fixed. And last but not least, we are also providing internal dashboards for the PR authors to basically see all the related findings. All the comments that we are posting are the ones that are deemed important by the cloud security team. So basically, developers will never get more than a couple of findings. Basically, we are trying to avoid posting all of the findings that we detect. On those internal dashboards, we are monitoring a couple of things. So first and foremost, total number of findings. But this number on its own doesn't have any context. So we are trying to provide more metadata and break it such as severity, resource type, cloud, location, team, and so on. So we are able to provide more context. It also provides us to collect overall trends. So basically, if we see that the overall number of findings is increasing or decreasing over time, so this is actually a good benchmark how the remediation process is going. We are also able to spot emerging security findings. So, example, somebody creates a Terraform module or they find the configuration, they start copying it from different sources. Then we can see that there is a sudden spike or increase in findings of a particular type. And also to provide a good developer experience, we are monitoring performance data such as scan duration. So we are constantly able to say or basically tune the scanning engine so it doesn't take days to scan the repository. and also the failure rate. So basically be able to provide some monitoring in case something goes wrong. So let's move towards the runtime detections. So in Datadog, we are using a standard cloud security posture management scanner. So CSPM is a set of tools or scanners that basically work by analyzing active cloud resource configurations and checking particular directives. In Datadog, we are in a bit special situation as the cloud security team is customer zero of our internal CSPM tool that we develop. And main use cases when we were choosing which tool to use were basically ability to scan misconfigurations in a multi-cloud environment, able to provide trending, and to see how we are doing over time. This is especially important when we are trying to measure the performance or actually benchmark the remediation process. And we are also collecting data. So for example, if you see that there is a sudden spike of a new findings, or we see that some of the findings are repeated over time, basically what we are trying to do is that by analyzing this data, we can then collect the data, look at it, and every quarter as we are planning our objectives, we can just go forward and prioritize the remediation by developing tools, procedures. So basically we are able to tackle them in a more systematic manner. On this screenshot, you can see basically a screenshot from the CSPM that we use. So basically every time when we have a finding, we see the OLR location within the cloud or the context and findings. If you would click on a particular finding, you would get information how to fix it, what is the impact, and so on. Now that we covered the runtime detections and the pull request mode, we still have a problem that we need to chain together the findings. So let's say that on runtime we detect particular finding, but we are not able to know where exactly it is located. So for this reason, we have the so-called check-out schedule mode, which runs daily and scans all Terraform repositories. It is responsible for collecting data, to collect the data, so we can get a bigger picture matching trends, as well as the location of the particular resource mapping within the source code, and then through parsing the Terraform state and, for example, using the resource errands, we can just pinpoint where exactly which resource is located in which source code, which repository. And we are providing the dashboard as well, but it's pretty much the same dashboard that is used for the PR mode with just some different variables. Okay, so now let's look into remediations. So when I was thinking about the remediations, I was thinking like what were the common challenges. So imagine that you are a security team and I'm a security team member, and you pretty much know the situation that you want to report the misconfigurations to a team one. They will tell you that they will prioritize it. Then to the second team that they put it into the backlog. Then as time passes, you check it, 9 months later, you still realize that it hasn't been fixed. So basically, owner engagement is a challenge number one. Looking at this from the non-security team perspective, is that imagine that they receive 10 different requests from various members of the security team, and over time they basically get swamped with the request and they don't know what to do with it. So basically they will start acknowledging and never fix anything because they don't know what to prioritize, which request is the most important. So let's say that we were lucky enough and the remediator who happily accepted to fix the misconfiguration. So they look into the findings and they read the remediation steps. So they go through pages and pages of documentation, and after spending almost a day figuring out what they have to do, they will just give up because it's just too complicated. So basically we lost the remediator and the issue is not going to get fixed easily. And my all-time favorite. So we are in a situation where we are able to detect findings. We have a means and tools, procedures to know how to fix these findings, and we just have to contact the owner. But then when we try to figure out who are the owners, the actual problem is who are the actual owners. So this led us to define a couple of requirements, what we expect from remediations. So first and foremost, simplicity. So it has to be clear what has to be done, how it has to be fixed, what is the impact. If we ask people to take action and we have classes or misconfigurations, we are always trying to tackle them in a systematic way by providing tooling or some tooling or procedures so it's easy for them. And side effect of this is that this is also time efficient. Basically, we found out that faster they can remediate, more likely it is that the remediation itself will get prioritized. Ideally, you don't want to deal with the remediations because all of the security best practices will be part of the development. So basically, people don't have to deal with it. But if they have to, it's always important to engage with stakeholders by making them part of the wider security community within the company. So this is basically, imagine that you are working or organizing hackathon, you always try to have a mixed teams, or when you are developing procedures and processes, you are always having people in mind, and you ask actively for feedback, and you are also open to feedback. So how do we deal with remediations in Datadog? So first and foremost, we tackled it in a multiple layers. So we built a security community within the engineering team. So we run our own security champion program where we appoint person from every team directly. And this person is basically a point of contact for any security related question. So for example, we have an incident and we don't know what this service is about, what is the contact. We always reach out to the person, and this person is then able to provide us the context. And every quarter when we are planning our objectives, we are always planning them in a way that we have a stakeholder from product or a platform team. So we never try to solve a problem that the other teams are not suffering. So what this actually helps us is that as we start working on an objective, example, developing a procedure or a tooling, we always collect the requirements and involve stakeholder within a development phase early, which actually helps us because if they tell us that they like it or this is not good, what happens is that we are moving forward with an iterative approach. And we trade over time, and we are not afraid of failing, and we are basically trying to fail fast. It's very important to understand that what might work for company A might not work for company B because of different culture, business needs, priorities, and so on. But having that lesson learned is always valuable to have because then we can know what actually works and what doesn't. And with remediations, it is always important to do things that actually get traction and actually you are able to work. Second big part is basically providing Terraform modules, where we basically provide the modules for most commonly used Terraform resources. Our philosophy here is that the best way for people to deal with security is that they don't have to deal with security at all. So this is actually good because then people want to use S3 bucket, they use S3 bucket, and the module has a standard security settings. This is especially good for new resources because imagine that there is a new misconfiguration detected in this resource, and we know that this resource is backed by the module. We can always implement the fix in the module and just ask the remediator to bump the version. And we are also in a process of migrating existing resources to modules. and this might require a lot of effort. But this is something that should always be prioritized, because in mid to long term, this will provide multiple benefits, such as standardization, easier upgrading, and so on. On this picture, you can see an example of our S3 bucket module. So when person wants to create module, actually the bucket, we are actually asking him to provide 3 different parameters, like the bucket name, the owner of the team, and the repository from which it's called from. And for example, the security settings are set in a way that they are secure by default, and they can be changed, but they are not mandatory. And then also the internal documentation provides an example how these modules can actually be used. So basically, all of the non-required attributes are just to further expand or configure the bucket, unless we need something non-standard. Moving forward, the part of the last resort remediation is something we call automated remediation. We have an in-house built solution on top of cloud custodian, where we scan the cloud resource configurations on a regular basis, and then we try to fix them as soon as possible. Problem with this approach is that it is not very compatible with the infrastructure as code approach to managing infrastructure, as we would be doing changes outside of the Terraform. Though to basically circumvent that, we are trying to provide automated remediation just for findings that basically would result in utter disaster. So for example, if a buckets are public, but they have not been put into an exception list, they would be remediated. And special care is taken by the tooling that we don't delete resources that we are not supposed to delete. For this, we spent a lot of time trying to tailor IAM policies in a way that we restrict or add additional safeguards. So to summarize, security is already hard enough, and we don't need to make it harder. Most of the companies are good at detecting issues. There are a lot of good tools out there on the market, but most companies are actually horrible at fixing them. So basically, focusing on remediation might actually be more valuable than on detecting. I would really like to mention this to non-security people as well as security people, that if you're a non-security people and security team asks you to fix something to using a process or tool, but the tool sucks or it is very hard to use, be honest and tell it to them, and they will have to fix it, and they will be more than happy to do so. And always start small and expand over time. It's better to cover, let's say, 5 findings and get the remediations done for them than be able to detect 2000 findings and get remediation done for 0 of them. And that's end of the presentation, and times for question. Thank you.